Imagine looking up at the night sky and seeing not just a star, but a visitor from a time before our own sun existed. This is exactly what happened on July 1st, 2025, when astronomers operating the Atlas Survey telescope in Chile spotted a faint, fuzzy object moving against the backdrop of distant stars. This was no ordinary comet or asteroid from our neighborhood. Its path was all wrong, a clear indication that it was an interstellar traveler, a guest from another star system. This celestial wanderer was named 3I/Atlas, with the 3I signifying it as the third interstellar object ever confirmed by humanity, a successor to the enigmatic Oumuamua and the comet Borisov. What makes 3I/Atlas so utterly captivating is not just its foreign origin, but its incredible antiquity. Scientists quickly realized this was something profoundly special, a relic from the deep past. As the comet drew closer, its icy body began to react to the sun's warmth, releasing a cloud of gas and dust known as a coma. This activity confirmed it was a true comet, but unlike any we had encountered before. Its journey had been unimaginably long, a silent pilgrimage through the vast, cold emptiness of interstellar space, carrying with it secrets from the very infancy of our galaxy, long before Earth or even our solar system had formed. The discovery was a moment of pure scientific excitement, a testament to how our constant watch over the heavens can yield the most unexpected treasures. Pre-discovery images found after the initial alert showed the comet had actually been lurking in our cosmic backyard since at least mid-June 2025. Each new observation added another piece to an extraordinary puzzle. This wasn't just a rock, it was a time capsule. It offered a tangible piece of another, much older part of the Milky Way, delivered directly to our doorstep for study. For scientists, it was like an archaeologist unearthing a sealed tomb from a lost civilization. This remarkable object is currently hurtling through our solar system at a staggering speed of over 130,000 miles per hour, or 210,000 kilometers per hour. Its trajectory is a hyperbola, a stretched-out curve that proves it is not captured by our sun's gravity. It is here for a fleeting visit, a brief swing through our planetary system before it continues its endless journey back into the interstellar void. This single pass is our only chance to study it, to decode the messages locked within its ancient ice and dust, and to glimpse the conditions that existed in our galaxy billions of years ago. The story of 3I/Atlas begins in a place far, far away and long, long ago. It was born in a solar system much older than our own, orbiting a star that likely formed in a different part of the Milky Way. Analysis of its trajectory suggests it hails from what astronomers call the galaxy's thick disk. This is a diffuse, ancient population of stars that surrounds the thin disk where our sun and most of the stars we see at night reside. These thick disk stars are relics from an earlier, more chaotic era of galactic formation. They are the venerable elders of our cosmic city, and 3I/Atlas is a piece of one of their long-lost children. For countless millennia, this comet orbited its parent star, a silent witness to the formation of its own planets. Then, a gravitational disturbance, perhaps a close pass by another star or a giant planet, flung it out of its home system. This cosmic eviction notice sent 3I/Atlas on an incredible journey, casting it adrift into the vast ocean of interstellar space. For billions of years, it drifted through the Milky Way, a lonely traveler in the dark. It has spent more time wandering between the stars than our own solar system has existed, a concept that is almost impossible for the human mind to fully grasp. Its long voyage saw it pass through stellar nurseries, past dying stars, and through immense clouds of gas and dust from which new stars would eventually be born. All the while it remained in a state of deep freeze, perfectly preserving the chemical makeup of its birthplace. This is what makes it so invaluable. It is not just a rock. It is a pristine sample of the raw materials that were present in our galaxy billions of years before our sun ignited. This cosmic messenger traveled from the direction of the constellation Sagittarius, finally crossing the threshold into our solar system to give us a glimpse of our galaxy's distant past. The sheer scale of its journey is breathtaking. It has likely traveled for hundreds of millions, if not billions, of years across interstellar space. Its path was not a straight line, but a meandering drift through the galactic currents, shaped by the faint gravitational pulls of countless stars and dark matter. Now, Its temporary path through our solar system is bringing it into the light. The sun's energy is causing it to shed its outer layers, giving astronomers a precious opportunity to analyze the ancient materials it has carried across such an immense expanse of space and time. The most astounding fact about 3I/Atlas is its incredible age. Current estimates place its formation at around 7 billion years ago. To put that into perspective, our entire solar system, including the Sun, Earth, and all the other planets, is only about 4.5 billion years old. This means that 3I/Atlas is a staggering 2.5 billion years older than our own world. It was already a fully formed comet, drifting through the galaxy when the cloud of gas and dust that would become our solar system was still just an unremarkable nebula. It is, without a doubt, the oldest comet humanity has ever had the privilege to observe up close. This immense age is precisely what makes it a scientific goldmine. Because it comes from the galaxy's thick disk, it provides a physical sample of the chemical environment of the early Milky Way. The building blocks of planets, things like water ice, carbon compounds, and other organic molecules might have been different in that ancient era. By studying the light reflected from 3I/Atlas's coma and tail, scientists can determine its composition. This allows them to effectively perform galactic archaeology, analyzing a fossil from a time and place in the universe we could never hope to visit directly. Think of it this way: the comets in our own solar system, like those from the Oort cloud, tell us about the conditions when our sun was born. They are local history, but 3I/Atlas tells us about galactic history. It's the difference between finding an old family photo album in your attic and discovering a lost manuscript from an ancient, forgotten library. This comet carries information about the abundance of key elements in a much older generation of stars, which can help us refine our models of how the galaxy itself has evolved chemically over billions of years. The comet's size also makes it a significant object of study. Early observations suggest its coma, the glowing cloud around its core, could be as wide as 15 miles or 24 kilometers. This indicates a fairly large and active nucleus, the solid body of ice and rock at its heart. A larger object provides a stronger signal for our telescopes, making it easier to analyze its composition in detail. Its great age means it has survived billions of years of cosmic radiation and potential collisions, making it a remarkably resilient survivor from a bygone era of cosmic history. The arrival of 3I/Atlas is more than just a celestial spectacle. It's a profound scientific opportunity. Every interstellar object that passes through our solar system offers a unique data point, helping us understand our place in the universe. By comparing the composition of this ancient comet with our own, we can begin to answer fundamental questions. Are the ingredients for life, like water and organic molecules, common across the galaxy? Or does each star system develop from a unique chemical recipe? 3I/Atlas provides a crucial piece of evidence from a completely different and much older planetary nursery. Its journey through our solar system is being meticulously tracked. The comet will reach its closest point to the Sun, known as perihelion, on October 30th, 2025, when it will be just inside the orbit of Mars. This is close enough for the Sun's heat to cause significant outgassing, making it brighter and easier for observatories like the Very Large Telescope to study. Importantly, it will remain at a very safe distance from Earth, passing more than 170 million miles away. There is absolutely no threat of impact, allowing us to observe this visitor with pure curiosity and wonder. The study of 3I/Atlas also helps us understand the dynamics of planetary formation. The fact that it was ejected from its home system tells us that the process of building planets can be a violent and chaotic one, with gravitational interactions powerful enough to fling entire worlds and comets out into interstellar space. By studying how many such objects exist, we can better understand how common it is for solar systems to eject material. This, in turn, informs our theories about how stable or chaotic other planetary systems might be, and what the chances are for life to develop and survive elsewhere. Ultimately, 3I/Atlas is a beautiful reminder that our solar system is not an isolated island, but part of a vast, interconnected galaxy. It's a messenger that has crossed an unimaginable gulf of space and time to tell us a story about our own cosmic origins. While we have no missions planned to chase it down, the data we collect during its brief passage will be analyzed for decades to come. With new observatories like the Vera C. Rubin Observatory coming online, we expect to find many more of these interstellar travelers, each one a new chapter in the grand unfolding story of the cosmos.